is going to go through an inelastic collision and then a totally inelastic collision. So in this first one, it says we've got coconut chips, and I chose coconut chips, coconut chips for example because that's your lab. However, your lab will not be this simple because your lab will be in 2 dimensions, and we haven't talked about that yet. But anyway, so you've got 2 coconut chips. One runs into the other. We know they have the same mass, so that's nice. That makes the question easier. And we know the initial velocity of the white one, but we know the first one starts at 0. Then what it's saying is, if we can measure the initial or the final velocity of the black one, then what is the final velocity of the white one? Okay, that's the question. We're saying north is positive. We'll call it that direction, and we start to solve. Now I've told you it's inelastic, but let's say, how would you know, right? The reason how you would know, because I don't clearly state it to be elastic, you assume, and it certainly doesn't state that they stick together. There's no reason to think they're going to stick together. That would be your assumption, okay? A, you're not told otherwise, specifically told otherwise, and B, you're not told that they stick together. So that inelastic, so here's the only formula that applies, so you write that down right away. The nice thing in this particular one is because the masses are all the same, they cancel out of the equation. You could factor them out of both sides, divide both sides by m, and they're gone. Okay, so there's no masses, they're all out. And then you just sub in the numbers. We know 3.4 is VW1, and we know 0 is this one, equals this speed plus this one. And so, I mean, it's not that hard. You just solve for it. So you can say the answer is just, you call it just 2.2 as positive, so to speak, because we called north positive, or you could answer it just calling it north. Okay? And the number makes sense, certainly with the context of the problem. It slows down because it's given some of its momentum to the black one. That's what happened in that interaction. It still has a momentum, but it gave some of it to the black one. Okay, so that's a simple inelastic equation. Again, go ahead and an inelastic collision, sorry. If you need to pause, please do, but I'm moving on. Okay. Snowball fight. 2 snowballs, that's their mass, they collide midair, and imagine they don't break apart, imagine they just stick together. That'd be pretty cool, but maybe it doesn't really happen, but imagine it did. Okay, so right here. So first of all, I tell you it's a completely inelastic, but if I didn't say that word, you'd know because somewhere in there it'd say they're stuck together snowball. That means totally inelastic. Okay, so we know the mass of each to begin. We know the speed of each beforehand. They're going in opposite directions. One's 22 north, one's 15 south. I'm going to call north positive again, same as last example. And I want to find their common velocity afterwards. Okay? So how do I know totally inelastic? Well, A, it told us, but B, I used the word stuck together. Okay? So that's the information I know. So the equation, here's my conservation of momentum equation for a totally inelastic collision. Sub in everything that you know. This time you can't necessarily just cancel out the mass because MA plus MB, so that's the 0.3 over here. Notice this is negative now, that's because VB is negative, okay? So I'm still adding, but I'm adding a minus. And just rearrange and solve, and so the common velocity afterward is 3.5 meters. Now let's see if that makes sense. They're both the same mass. This one's traveling 15 to the south, and this is traveling 22 to the north. When they run in together, they're going to have a common velocity, and there's more momentum in this situation to the north. So it makes sense that the answer is north. It also makes sense that it's smaller than either of these, right? Because it's like these two cancel each other out a little bit, right? And so yes, it makes sense. Very important with these collision problems to think about what you would expect to happen, and does that match what actually happened? Okay, I'm going to stop here. The next one is the elastic one, which is really long. So I'm going to stop and then start a new video just for the elastic one, just because it's so long.